since we are substituting x equal to some other variable, so limit of integration will also change. Here we write the initial variable which is x, here is the new variable which is t. X is from 0 to infinity, so when we put x equal to 0 here, we get t also 0. When we put x equal to infinity, we get t equal to infinity. Now our new equation of I2 will become 0 to infinity e raised to minus x raised to 4, we are substituting it as t, and x square. X is t raised to 1 by 4, then x square will be t raised to 1 by 4 the whole square, which is t raised to 2 by 4, which is t raised to half. So x square is t raised to half. What is dx? Dx is nothing but this term, which is 1 by 4 into t raised to minus 3 by 4 into dt. So this is our I2. So now this 1 by 4 can be taken out of the integration sign because it is a constant. So 1 by 4 integration of 0 to infinity e raised to minus t. And this t and this t can be combined. So t raised to half into t raised to minus 3 by 4 is nothing but t raised to half minus 3 by 4. Okay, so we take the LCM here. So we get t raised to 2 minus 3 by 4, which is t raised to minus 1 by 4. So this 2t will combine and we get t raised to minus 1 by 4 into dt. So now if you compare this equation with this equation, these two equations are similar. So what is n minus 1? N minus 1 is nothing but minus 1 upon 4. When we take this one here, it will be minus 1 upon 4 plus 1, which is 3 upon 4. So this whole term is nothing but gamma of n. N is 3 by 4. So our I2 is 1 by 4 gamma of 3 by 4. This is our I2. This is our I1. Okay. So the final solution will be I1 into I2. So our I will be I1 into I2. And we got I1 as this value and we got I2 as this value. So we substitute that. I will be I1 into I2. We got I1 as 1 by 8 into gamma of 1 by 4, and we got I2 as 1 by 4 gamma of 3 by 4. So this 1 by 8 and 1 by 4 can be combined as 1 upon 32, and here we have gamma of 1 by 4 into gamma of 3 by 4. So now how to solve this part? If you know, we learnt one property when n is between 0 and 1. We have gamma of n and gamma of 1 minus n will be pi upon sine of n pi. So this is our property. So in this case, if we consider n equal to 1 by 4, so this is gamma of 1 by 4, and gamma of 1 minus n, that is 1 minus 1 by 4 is nothing but 3 by 4. So these two terms are matching with this property. So these two terms can be represented as pi upon sine of n is 1 by 4, so sine of pi by 4. And what is sine of pi by 4? Sine of pi by 4 is 1 upon root 2. This root 2 will go in the numerator, it will become pi root 2. So this term is nothing but pi root 2, and in the denominator we have 32. So we can further simplify this. 32 can be written as 16 into 2, and 2 is nothing but root 2 into root 2. So 2 is root 2 into root 2. 1 root 2 will get cancelled and we get I equal to pi upon 16 root 2, and this is our final solution. So this is how we solve the problem on gamma function type 1. More such problems we will see in our next video, so stay tuned for our future lectures.